Okay, let's practice one more expression by using the rule sum or difference of perfect cubes. So if I look at my expression here, I have 2b to the fourth plus 54b. Well, it is two terms. It is connected by addition, so that is a sum. But these terms are not perfect cubes. First of all, my exponents are 4 and 1, and those are not multiples of 3. And my numbers 2 and 54 are not on my perfect cube list. We have to know our perfect cube list. 1, 8, 27, 64, etc. So remember, the first rule of factoring is always GCF. We need to divide these terms by the most they have in common. Well, 2 and 54 are even numbers, so they can both be divided by 2. B to the fourth and b to the first, we can divide by b. Remember, when we do the GCF of a variable, it's the term with the smaller exponent. So we write our GCF 2b, and we put one set of parentheses to tell me what's left. So 2b to the fourth divided by 2b would be 1b cubed, which is just b cubed. Positive 54b divided by 2b would be positive 27, and the b's would cancel out because they'd make the number 1, and 1 times 27 is still 27. So we pulled out the GCF. This is what's left. Now we reevaluate. Do I have a rule of factoring in here? Well, I have a sum. Now 27 is a perfect cube. It's on the cube root list. That list. B cubed is a perfect cube. It has an exponent that's a multiple of 3. So that means this expression will factor break down some more. So we have to know our rules. This is all memorized information. When I factor a sum of perfect cubes, it's a binomial times a trinomial. When I factor a perfect cube, I put my signs first. If it starts out as addition, it goes plus, minus, plus. Memorize it. To get my binomial, I say, what did I multiply 3 times to give me b cubed? That would be b. b times b times b is b cubed. What did I multiply 3 times to make 27? That would be 3. 3 times 3 times 3 is 27. Now, once you get the binomial, you're going to make the trinomial. You're going to square the first, square the last, multiply to make the middle. Take the first term and square it. B times b is b squared. Square the last. 3 times 3 is 9. Multiply these to make the middle. B times 3 is 3b. You already got the signs in there. You don't got to worry about signs. You got to get the terms in. Now, remember, before you even broke down the cube, you had to pull out the GCF. So you see this 2b? It's still part of the answer. This is the expression completely factored. Now remember, we could always check it by doing what operation? That's right, multiplication. So let's just take a walk down memory lane. Who remembers how to multiply a binomial times a trinomial? Do we do FOIL? No. FOIL is first, outer, inner, last. That's only for 4 terms. That's a binomial times a binomial. The only way we know how to multiply a binomial times a trinomial is like 3rd grade. We'd line it up vertically. So let's line it up. We take our trinomial, b squared minus 3b plus 9, and we multiply it to our binomial, b plus 3. Remember? 3 times 9 is positive 27. 3 times negative 3b is negative 9b. 3 times b squared is positive 3b squared. We're done with the ones place. Put my placeholder. b times positive 9, positive 9b. b times negative 3b, negative 3b squared. b times b squared, b cubed. Just like 3rd grade, I'd add up my columns, my like terms. I have a b cubed. Positive 3b squared and negative 3b squared would add to make 0b squared. I don't have any. Negative 9b, positive 9b would add and make 0b. Don't have any. 27 plus 0 is 27. Now you're going to say, well, that's not the original expression. You're right. That was just multiplying the binomial times the trinomial. Now we got to multiply that by the GCF. So if we have 2b and we want to multiply it to b cubed plus 27, don't we just distribute? So 2b times b cubed is 2b to the fourth. 1 and 3 is 4. 2b times 27 would be 54b. Now are we back to the original expression? We sure are. So remember, with factoring, you can always check by going back and multiplying. If you do the GCF rule, make sure you have the GCF in your final expression that's in factored form. All right, we are now ready to put the whole concept of factoring all together in our last module. See you then.